Hi everyone, this is part 7 of the ACT practice test that I've linked below. This is page 30 on the actual test. Once again, I'm not affiliated with ACT and these are not my problems. I'm just doing them as an explanation to help anyone who may need it. So let's go ahead and get started. Once again, I always circle the answers from the answer key that they give so that I know I'm getting back to the correct answer every time and not making a silly mistake. So here's the following information to answer questions 48 through 50. It looks like they give us a graph. It says the quadratic function f and triangle MPQ are graphed in the standard xy coordinate below. Points M, N, and P are on F. Point Q is not on F. So number 48 says, in terms of A and B, what is the area in the square coordinate units of triangle M? And here I'm going to kind of highlight this a little bit. MPQ. So we want to know what the area of this is. It's a triangle. The formula for the area of a triangle is 1/2 of the base times the height. So 1/2, let's find the base. This is the base. Let's see, it looks like we go 1, 2, 3, 4. So 4 across here. So the base is 4A. Times, let's find our height. It looks like we go from here up 1, 2, 3, 4, 5. 5B. So let's just do the math. Half of 4A is 2A. 2A times 5B. 2 times 5 is 10. And then you just kind of squish AB together. So that gets us letter G. I'm going to erase my work there so that I can write on it again if I need to. 49. Point M will remain fixed and point Q will move to the right along the x-axis. As Q continues to move to the right, which of the following statements describes what will happen to the slope? So let's see. If we start moving this point, so I want to know what happens if we keep moving it to the right. So let's first find the slope from M to Q just as it is. Slope is always rise over run. So I'm falling 1, 2, 3, 4, 5. So that's -5. And I run 1, 2. So originally my slope is -5 over 2. Let's move Q over. Let's say I move all the way over here to the right. So I'm still falling 5, but now I'm running 1, 2, 3, 4, 5, 6. So let's look and see which slope is bigger. It's kind of tricky when you get to negatives, right? Because this is technically like -2.5. So on a number line, just remember our slope is increasing here when we move to the right. The reason that is because -2.5 is like here on the number line. Here's 0, right? Here's 1. Here's 2. So -5/6 is closer to 0. So our slope is going to be increasing. So let's look which one will say our slope is increasing. A doesn't, B doesn't, C doesn't. It will increase but never be positive, or it will increase and eventually be positive. So the reason that it's D, it will never be positive, is because our slope is always going to look like this. No matter how steep our slope gets or how not steep our slope gets, it's always going to be going in a negative direction. Remember, this is a positive slope. That's what a positive slope looks like. This is what a negative slope looks like. So it's always going to stay negative. So that leaves us with answer D. And let me go back up here and erase this work real quick. I hope that makes sense. I know it's confusing when you don't have a number line. You think, oh, 5/6 is smaller. But remember, negative 2.5 is smaller. What are the following values for f of 5a? Which one? So let's see where 5a, here's 5a. We want to see where that intercepts with our f here. So I'm just going to draw a line up. Oh, it's hitting the graph right here at 8b. So f of 5a is 8b. All right. 51. 12 jurors are needed for an upcoming trial. The diagram below illustrates a part of the process of jury selection. The 12 jurors will be selected from a jury pool of about 60 people. The court records show that a trend that only 40% of people who are summoned for jury duty actually appear, and that of 1/3 are excused. If the same trend continues, how many people should be summoned to have as close as possible as 60 people in jury pool? Okay, so I'm going to label our summoned as X. It says 40% of those summoned actually appear. And then 1/3 of the appeared are excused. So that means 2/3 of the appeared are in the jury pool, which it says we want 60. So now let's look at the equation I just wrote for the jury pool. So we have 2/3, let's do this in our calculator, 2/3 times 0.04. Or you can make your life easier here. I'm going to actually show my work over here so you can see. So I need to solve for X. So I'm going to get rid of this 2/3 first. I'm going to multiply each side by the reciprocal. So those go away. So 60 times 3/2 is 90. So I have 0.4x equals 90. And get rid of that 0.4 by dividing. So 90 divided by 0.4 is 225, which gets us letter D. That one's kind of confusing. I'm sure there's other ways to do it. That's just the way I see would be easiest. 52. What is the 275th digit after the decimal point in the repeating decimal 0.6295 repeating? So I see 1, 2, 3, 4 digits. So let's take 275 and divide that by 4. 275 divided by 4, I get 68.75, or 0.75 is 3/4, right? So that means I go through this whole thing here. I rewrite this 68 times. And then at the very end, I go to the third number out of 4. So that would get me 9, which is letter K. Given that f of x equals x squared minus 4 and g of x equals x plus 3, what are the values of x for which f of g of x equals 0? So it basically wants to know f of g of x is x plus 3, right? Equals 0. Now it wants us to plug in x plus 3 to f of x. So it wants us to plug that in there. So I have x plus 3 squared, bring down the rest, minus 4 equals 0. Now I just got to solve this. So x plus 3 squared is x plus 3 times x plus 3. Do not ever, ever just distribute like that. Oh my goodness. I see that so many times. Don't do that. You'll get your answer wrong. You have to FOIL. It's a foiling problem. So we have first, outer, inner, and last. Bring down the rest of the problem. And let's simplify some things. 3x plus 3x is 6x. 9 minus 4 is positive 5. Now we have to factor this. We can shortcut factor. I need two numbers that multiply to be 5, always last number, and add to be the middle number. Well, 1 times 5 is 5, and 1 plus 5 is 6. And those are only factors of 5. We can't divide 5 by anything else. That's a whole number. So this factored is x plus 1 times x plus 5 equals 0. And now it's a zero product property. So you just split this up, set them both equal to 0, and solve them. So x equals negative 1 there. Undo addition with subtraction. X equals negative 5 there. So that gets us letter A. And our last one. Given that P is a positive number, N is a negative number, and P is greater than N, which of the following expressions has the greatest value? So I'm going to go ahead and I'm just going to label P as 2 and N is negative 1. Just going to keep this simple, plug these in and see what works out for me. So for this one, let's see, 2 minus negative 1 over 2 is 3 over 2. The absolute value of 3 over 2 is 3 over 2. Let's plug it in here. 2 minus negative 1 over negative 1. 3 over negative 1 is negative 3, but the absolute value of negative 3 is positive 3. So far, G is the greatest. And I know I already have that as our answer, but, you know, just keep plugging in. Let's see what we get. 1 over 3. That's not going to work because we want the greatest number. Over 2. 1 over 2. 1/2 is not greater than 3. 2 plus negative 1 over negative 1 equals what? 1 over 1, which is 1. And that is not greater than 3. So G is our winner and our answer. So that is page 30. It looks like we only have one page left. We're almost done. I hope this helped you out. Feel free to like and subscribe for the next section. Thanks. Bye.